Yes, today we are here in Frankfurt with a special guest directly from Los Angeles. Came Professor Aristo Vojdani, and we have a very interesting theme today. We talk about the gut-brain connection. At first, I would like to say thank you for coming this long way down from Los Angeles to Frankfurt. For this evening, we have this special seminar together with patients and physicians together. It's important that both learn these research results from you, and therefore I'm really happy, glad that you are here today. Let me introduce you quickly. You are a professor at Loma Linda University in California and an adjunct professor at the Lincoln College of Professional, Graduate and Continuing Education at the National University of Health Science. And your ongoing research focus on the role of environmental triggers in complex diseases, and you developed more than 300 antibody assays, live work, for the detection of autoimmune disorders and other diseases. You have 17 US patents on your name. Congratulations.
Thank you.
And you wrote over 200 articles and 2 books. Let me show you. This is the latest. Neuro-Immunity and the brain-gut connection, and food-associated autoimmunities when food breaks your immune system. What a title. Food is healthy. We believe food is good. And you write, food breaks your immune system. Very interesting. Let's see what you have to present us in a couple of minutes. You are CEO of Immunoscience Labs in Los Angeles, California, and Chief Scientific Advisor for Cyrex Labs in Phoenix, Arizona. And you are sitting in the editorial board of 5 scientific journals. And you received a lot of awards, the Herbert Winkler Award from the American Academy of Environmental Medicine. And just a couple of days before our meeting here, on June 6th, you received in Florida the prestigious award from the Institute for Functional Medicine, the Linus Pauling Award.
Correct.
Congratulations.
Thank you so much.
Very fresh, and it's really an honor for you for this award, and it's an honor for us to have you here.
Thank you so much. I appreciate it.
Now, at first, I think our listeners, our patients and physicians are interested in the point, how did you came to, into this field, environmental factors and immune system? What was the intention or the motivation to dig a little bit deeper in this connective reaction of immune system and environment, like chemicals and food? What was your attention in the university?
First of all, let me thank you for your friendship and hospitality in Frankfurt.
You're welcome.
We have been friends for many, many years, but we never had an opportunity to sit, talk to each other in such a beautiful environment. So, in 1967-8, I took my first immunology course. But before that, as I mentioned when I received my award at recent functional medicine meeting, the chemistry book that I learned from the first year of microbiology and biochemistry was the Linus Pauling General Chemistry book.
Linus Pauling.
Because chemistry is the basics of everything. How can you learn about immunochemistry if you don't know chemistry. So let's give credit to our great teacher, Linus Pauling.
Received 2 Nobel Prizes.
Correct.
Yeah.
Correct. Then when I took the immunology course, then a young professor, graduate of Pasteur Institute, who came to Israel, became professor, and started teaching us immunology. The first thing he told us, students, the future is immunology. I'm talking about 1965, 66, 67. I had 2 courses in immunology. And after learning or taking the 2 courses about immune system, the final was one question that we had to answer. Explain what is immune surveillance in 2-3 pages. So I did analogy of immune surveillance with police department, the army of the body at that time.
Yeah.
About 2 weeks later, the professor asked, "Who is Aristo?" I said, "Me." I thought I did something wrong. He said, "You had the highest score in the class, 100%. And so, congratulations, and can I invite you to visit my laboratory, and if it's possible, to work during the summer in my laboratory." And that was the beginning and ending for 7 to 8 years in that laboratory. Doing first just summer research program, and then for my master degree 2 years and 5 years for my PhD. And during this period of time, I learned about immunochemistry. What is happening, why and under what conditions chemicals as a hapten become antigenic, and we make antibody against the haptens as well as the carrier, which is the self-body proteins. And at that time, one of the best examples was that the professor showed us how to take penicillin. All of us, we think that, okay, antibiotics, yes, but they're chemicals.
Sure.
Yes, they work against bacteria, viruses, but they're toxic chemicals as well.
They kill structures.
Yeah, right.
Biochemical structures.
And so we managed how to bind penicillin to red blood cells. Because at that time, the methodology was agglutination, the way we do blood typing. What do we do? We take antibody against type A, type B, AB, and agglutination, we see that with naked eye. So that's the method was available. And so we showed that if we inject penicillin bound to human serum albumin to rabbits, mice, and we draw their blood, and through agglutination we showed that the animal produced antibodies against the combination of hapten plus the carrier, in this case were
The albumin.
the albumin. And we used penicillin bound to red blood cells to use that as a method to do agglutination and find how much antibody that rabbit produced against penicillin bound to human serum albumin. And this was just one method that I was very, very much impressed with it. Then, after finishing my master and my PhD and teaching for 7 years of immunology lab part, the professor was teaching the theoretical, I was teaching the practical aspect of the immune system. Then I moved to do postdoctoral studies, to make the story short, and then I went to work at UCLA, Harvard UCLA, Charles Rios School of Medicine, on cell-mediated effect of toxic chemicals or carcinogenic chemicals and cell-mediated immune function, particularly their effect on natural killer cell activity. When the chemicals suppress the activity of natural killer cells, and then in the absence of natural killer cell activity, the animal was developing cancer.
Cancer or other disturbances.
So we're learning everything, what happens from injection time until the animal develops cancer. But unfortunately, during these 4 or 5 years working in the laboratory, I became chemical sensitive myself.
So,
okay. So I went to a doctor, I'm sure you heard his name, Dr. Gunnar Heuser. Okay. He was a prominent doctor in Los Angeles, and he, at that time, he gave me IV vitamin C with glutathione. Detoxify my body.
yeah.
And then after several injections and all of that, he told me, Aristo, why don't you open a laboratory to help patients like yourself? And so that's how we started Immunosciences Laboratory. That through that laboratory, we helped thousands and thousands of patients who had chemical sensitivity and other environmental illnesses.
Great. Thank you very much. Now we have a picture what happened, what is the motor in you because of your own sensitivity to environmental, caused by chemicals. With the disturbance in the regular immune function, and you could help yourself by detoxification. You mentioned vitamin C, glutathione. Exactly, this is what we also recommend our patients.
Yeah, just clarify this point for those who are going to watch this program. Unfortunately, many doctors believe, or even scientists, believe that chemicals are small molecules. They're not antigenic.
Yeah.
Therefore, we do not produce antibody against them.
But the haptens.
Yes, but chemicals are haptens. By binding to human tissue components, they become antigenic and then can initiate autoimmune reactivity and finally may result in autoimmune disease. So we should not say chemicals are not antigenic.
Not too small.
They could become antigenic.
Because they changed the surface, they changed the protein sequence in our own body, our surface of our cells, and then the immune system said, oh, this is a foreigner. I have to attack this complex.
That's right.
So, and then the war starts. Now let's switch to the gut. We eat every day or every year, when I talk about tons of food, have to pass our digestive tract. A lot of food and chemicals in food and medication, antibiotics, other chemicals go through our gut. And there can exactly that happens, what you explained us. Chemicals can change the surface of some cells in the gut. Autoimmune reaction can occur, or borderline structures are attacked. And the gut opens, and as I explain it, my patients, many chronic diseases are caused by destroyed borderlines, like gut, lung, brain, and this is exactly what we would like to talk about today. is there a connection between a destroyed borderline in our gut and other parts of the body, like the brain? You know, we have this, you developed a very interesting test, antibody test, antibodies who are produced from our immune cells against structures in our borderline in the gut. May I ask you please to explain us which structures are attacked by the immune system?
Yes. So let me start first of all this way. Gut-brain axis is important in our understanding of our gut health and gut diseases, our immune health and immune diseases, and nervous system health and nervous system diseases. I think that is covering significant number of diseases. So yes, environmental factors by entering through food into the gut can have significant effect on gut immune function first. Particularly can affect regulatory T cell, which are regulating the immune system. That's number one.
And can downregulate.
Yes, correct. Secondly, can affect the structure of the gut barriers through different mechanisms. Example,
Uptins?
food, not good diet can change our gut microbiome. Bad gut microbiome can release, instead of beneficial molecules or peptides, they are going to release antigens or molecules such as lipopolysaccharides. And lipopolysaccharides can affect the tight junction, break down the tight junction proteins, as you can see in this picture. So, lipopolysaccharides and other molecules can break down the structural proteins such as occludin, zonulin. And then what happens when the gate is open? Unwanted molecules can penetrate the barriers, get into the circulation. So in this case could be the lipopolysaccharide by itself, the damaged tight junctions, occludin, zonulin, undigested food could get through, food additives, thousands of food additives. Could be from aluminum to food coloring,
Preservatives.
to microbial transglutaminase, which is added to so many foods.
Meat.
Everything gets through damaged tight junctions, and the job of our immune system is to go after them in order to protect our body against all these.
It's a regular reaction.
Yes.
This is
And
the
so
task.
it's making antibody to protect us against further damage, but unfortunately the antibody itself, due to antigenic similarity between some of these factors with human tissue, now the antibody is going to attack our tissue and setting the stage for autoimmune reactivity first, and after a few years to autoimmune diseases, which affects close to, I don't know, about 50 to 80 million individuals that just in the United States. More than 10% of the world population are suffering from some kind of autoimmune disease. And you and I We ask why autoimmunity.
Exactly, not how I have to treat it with corticosteroids or something like this. We want to ask what happens,
Yes.
what triggers this autoimmunity.
So this is breakdown in the tight junction
Yeah,
due to
and we have
environmental factors and change of our gut microbiome results in many autoimmunities. Furthermore,
we talk about the transcellular penetration when we can measure antibodies against the actomyosin IgA. Right?
Yes.
Yes. Against
Yes.
actomyosin, because this is a structure in our cell that gives us the shape of the cell, and when there are antibodies, we can see here in the picture, then the antibodies attack directly the cell structure and destroys the cell. This is the transcellular penetration. And then you mentioned the occludin-sonulin structure. Here, these colored connections between the cells. When we have antibodies against this structure, then we see here in the picture what happens. We have the paracellular.
correct. I'm very happy that you mentioned that because bacteria such as E. coli, Salmonella, Shigella not necessarily have to break the tight junctions. Sometimes, like a syringe, they inject the toxins inside the cell.
And they destroy
That's why you said transcellular. And therefore, they get through the cell, destroys the cells, the actomyosin and other components get released. We produce antibody against
And
that.
this is important, I think, because, we measure several years now the sonulin developed by Fasano, and that's very interesting. But in many patients, we measure regular sonulin levels, but the patient has a disturbed gut barrier. That means when the cell is completely destroyed, like here in the transcellular attack, then the cell isn't able to produce sonulin.
Yeah.
But we measure with your test, with the antibody test, we can discover these.
You may ask me why we measure antibodies. Why we measure antibodies? I'm an immunologist.
Because the tissue
Let's
is
take
destroyed.
example of lipopolysaccharides.
Yeah.
What do you think is the half-life of lipopolysaccharide in our body?
A couple of hours.
This was published in Journal of Immunology.
Yeah.
4 minutes.
4 minutes.
4 minutes.
Here is the lipopolysaccharide.
Yeah.
It's the surface of a gram-negative bacteria you see here in the picture.
Yeah.
It lives only
4 minutes.
4 minutes.
Half-life. Okay?
Okay.
That's very important. Why? Because our immune system job is to remove large molecules,
Away from,
the phagocytes.
yeah.
Dendritic cell's job is to remove these molecules. So therefore, you mentioned zonulin. Again, as an immunologist, if you measure zonulin, I published about this in the World Journal of Gastroenterology. We measure zonulin throughout several days. One day, in the morning, like this, low, and then it goes high,
high.
and then low, and so we call that fluctuation.
Yeah, okay.
So therefore, it's not, you cannot measure zonulin. With all due respect to
Fasano.
Fasano who
Yeah.
discovered this,
Yeah.
this little guy is an immunologist and saying that due to fluctuation, immune system is going to react to
Up
that,
and down.
making antibodies. But the difference is antibodies at least are stable for 21 days
So, and there
versus few minutes or couple hours.
and there must be a reason why the antibodies increase.
Correct.
And
Correct.
continuous attack by bacteria.
Yes. Yes.
You have too many LPS, endotoxins,
Yes.
and then the immune system does what it has to do. It attacks.
So that's why we measure antibodies against lipopolysaccharide,
Yeah.
against zonulin, occludin, and
Yeah.
actomyosin, which is part of the intestinal antigenic permeability screen.
Exactly. There's an interesting paper. You show this in your lecture this evening. I think this is very interesting. If you measure antibodies against lipopolysaccharides, then these reaction, these antibodies, as we see here, open barriers, other barriers.
So let's go back to what I mentioned before. Environmental factors, changing the gut microbiome. The gut microbiome releasing all kinds of toxins. Lipopolysaccharides can go into the joints. That's why relationship between arthritis and leaky gut.
Yeah.
Some of these bacterial toxins can damage the blood-brain barriers, causing inflammation
In the brain.
in the brain.
Yeah.
So it is very interesting that in this article, in this short article, we showed that about almost more than 50% of individuals who make antibodies against zonulin and occludin, also they make antibodies against S100B, which is part of the blood-brain barrier proteins, aquaporin, which we'll talk about this later, as well as claudin and claudin 5 or claudin 7, which are also part of the blood-brain barrier proteins. So yes, there is overlap between the two. So individual who is suffering from leaky gut also may suffer from leaky brain. That was the message in this article.
Thank you very much. We are on the brain. You have such a beautiful picture. We see here the endothelial cells. Also, you mentioned the tight junctions in the gut. But the same word we can read here in the brain. You see these little connections are also tight junctions. And where is the connection between the gut cells, the epithelial cells, and the endothelial cells? The next picture shows this. May I ask you to explain
Yes,
us
please,
this?
please. Thank you so much. So when we look at structures of gut epithelial cells, we have 3 layers of protection. So first of all, we learned that it's not easy to break the tight junctions in the epithelial cells. You see 3 layers: tight junctions, adherent junctions, and desmosome.
Here we see it. Yeah.
So those are 3. So, but in the endothelial cells, we have the first 2, but not the third one. So there is at least 60% overlap, 70% overlap between structural proteins of the gut epithelial cells
and the
endothelial cells in the brain. And that's why cross-reactive antibodies that we showed in that article. In addition to lipopolysaccharides, many bacteria also produce bacterial cytolethal, look at the name, bacterial cytolethal distending toxins, BCDT.
There's an A, B, and a C.
You see that also transcellular, paracellular damage.
That means these are chemicals. They are able to attack structures in our cells, in our, these, you mentioned the actins and claudins, and these structures are destroyed. That means the house is collapsing and destroyed. This bacterium toxin can destroy the cell, and then the gate is open.
Yes. Entry of all those molecules results in antibody production against BCDT itself, the bacterial toxins.
This is CDT here.
LPS, cytoskeletal protein. and tight junction proteins and food. And this is one of the main reasons we produce antibodies against food antigens that may result in food sensitivities, for example, non-celiac gluten sensitivity and other food sensitivities.
That is important, the non-celiac gluten sensitivity. I hear it every day in my clinic. My patients say, yes, I was in a university clinic. The doctor said, no, you don't have celiac disease. You don't have wheat allergy. No, you can eat everything. But the patient suffers from symptoms. So I show my patients this picture explaining what that our wheat corn, in Germany it's a corn, corn is is Mais natürlich, but Weizen, corn, wheat. Wheat is contains gluten proteins, but also other interesting structures like non-gluten peptides. It can be that it's not a gluten problem, but a problem against non-gluten peptides. The lectins may play a role, and then we have the different transglutaminases 2, 3, and 6. That is interesting. Let me jump to the beginning. You see here one structure in the wheat corn is the gliadin. They call it here in the
toxic
peptides. Toxic means gift in Germany. Es sind giftige Partikel. There are toxic particles in the wheat, and if you are not able to digest the food correctly, then we have particles which are toxic to our barrier. And interesting is the transglutaminase. If we have antibodies against transglutaminase 2, 3, and 6, can you explain what
Definitely.
Is it connected to different tissue?
Let me give you a little bit introduction how our brain works. I'm sure you. So one of my patents that out of 17 was how to detect reliably Lyme disease. And when I was reading many articles in the scientific journals, they were saying that after tick bite, the spirochetes get into our body, it changing its antigenic structures in order to hide from immune system. And then the question was, so why we measure antibodies only against proteins that have spirochetes grown in culture, not against the antigenic components we change in our body. So that was my first patent. So yes, we have to measure antibodies against Borrelia grown in culture, and also those antigens that changing during infection, human infection. So I was thinking also about celiac disease. I said, I know for sure that there are many proteins in wheat. There are many peptides in wheat. Why we are measuring antibodies?
Only one.
One, alpha-gliadin 33.
Yeah. Yeah.
So that was really the beginning of developing these tests.
That is interesting.
In 2009, I developed this test.
Amazing.
And so that's the idea, to measure antibodies against all, as much as possible, components of wheat, including wheat germ agglutinin. Transglutaminases, if we have transglutaminase 2, that they measure only that. Okay? So no, we said we have to measure antibodies against transglutaminase 6, 3 and 6. 3 is mainly found in skin. That's why dermatitis herpetiformis.
That means if I eat wheat and my immune system reacts to transglutaminase 3, then it may be the cause for my skin disease.
Correct. And transglutaminase 6
is brain.
in the brain, gluten ataxia. And finally, not to forget, microbial transglutaminase. It's hidden transglutaminase
In the food.
added to many, many foods. Sometimes the steak that you eat actually is
Transglutaminase.
putting together pieces of meat
Yeah.
to look like the most beautiful steak
Yes.
that you and I may eat without knowing that. So therefore, we react to that, and due to
sausages.
similarity between different transglutaminases, we make antibodies against all transglutaminases.
That means the cause of skin disease are like a dermatitis or transglutaminase 2 is connected to gut reactions and transglutaminase 6 to brain. That means chronic neurological reactions can be caused by antibody production against transglutaminase 6, one part of wheat, the healthy wheat. You
Yes.
know, it's people say we eat whole grain and this is healthy, and it cannot be the cause of any disease.
So I read
we
one.
can measure this exactly.
One of my patents is about differentiation between celiac and non-celiac gluten sensitivity, because that's, as you said, patient is having symptoms, goes to gastroenterologist, no transglutaminase 2 antibodies, no antibody, mainly IgA, against alpha-gliadin 33-mer, you don't have celiac disease.
Exactly.
And also histology shows normal.
Yeah.
But the patient is having symptoms. Why? Because that patient make antibody against Weger-agglutinin,
Or transglutaminase, whatever.
against opioids, whatever, the others.
Exactly.
Okay? And finally, against the transglutaminase, we had a doctor that I know had a patient suffering from horrible skin disorders. Goes from doctor to doctor to doctor. No one could help him. Finally, one of the doctors ordered this panel. Transglutaminase 3 antibody was highly elevated. He started removing gluten from the diet of these individuals after a month. Everything cleared from the skin. And so here, something so simple
Exactly
could
what
prevent years of suffering.
Exactly what I observe in my clinic. I tell my patients avoid for when we measure antibodies against these structures. Then I recommend to avoid wheat for 2 or 3 months at first. But exactly what I observed, after 4 or 5 weeks, you see skin is clear.
Yeah. The last thing I would like to add in here regarding this panel is, although that we have a patent, but there are some laboratories in America, they're ruthless. They're only after making money. They copied Cyrex and they claim they are the original ones.
Oh.
Okay?
Oh.
And okay, so
Yeah.
there are lots of copiers out there, but we are the original.
We like the original.
Thank you so much. I always give the analogy of the ladies, they buy these expensive purses.
Yeah.
Right? You know, $5,000, $10,000.
Yeah.
But you can buy the same look alike
Yeah.
for $50,
Yeah.
not $5,000.
Yeah.
So which one is the original? Which one is the best? The original.
No, sure. No.
Beautiful picture.
This picture shows the attack to the myelin structures in our axons, which happens in the multiple sclerosis disease. And here I would like to ask you, which role plays milk in connection to the multiple sclerosis?
Thank you for asking that. I'm going to answer it this way, that first of all, Dr. Runow, our conversation is based on science.
Yeah.
2 or 3 different articles were published. One in Proceedings National Academy of Science. Another one in Scientific American, and before that, also years before, about another component of butyrophylline from milk,
Yeah, very interesting.
alpha casein, beta casein, cross reaction with myelin-associated glycoproteins and oligodendrocytes. They're feeding the neurons.
They kill the neurons.
Yeah,
I should-
they're supporting the myelin sheath.
This is one of our patients, or one sample report. And what is interesting, that you have a lot of structures from milk. You see here, you have cow's milk in the program, you have alpha casein. Casein is the main structure also in goat's milk and
Yes.
milk.
Yes, 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 yes.
Some people believe it's perhaps helpful to avoid cow's milk and everything is good. No, it's not good. We have to check whether we have antibodies against casein. And here, this is milk butyrophylline. I never heard about that in my university or years before. We know each other. The milk butyrophylline, like in this case, this person has high antibodies against milk butyrophylline. In this case, I recommend to strict avoid milk products.
Yes.
Because these antibodies can attack the axon we saw in the picture.
The same idea that applied to Lyme disease, to gluten and non-gluten sensitivity, also applies to different components of milk. That's why we do all of that. And interestingly, you see in this patient reacting to all the components of milk.
Yeah.
Without any shadow of doubt that this patient is milk sensitive.
This is very clear in the red. We see in the red part of this report.
And in these individuals, if we will not remove milk products from the diet, these individuals may develop full-blown multiple sclerosis or Sjogren's syndrome or lupus in years to come.
Yeah.
And so therefore your job as a medical doctor is to remove
Exactly.
gluten and dairy from diet of patients, those even who have a family history of patient with multiple sclerosis or other autoimmune diseases. Sometimes even I say you don't have to spend money and do all this expensive testing. Just remove gluten and dairy from your diet and you see significant improvement in their clinical conditions.
But if you measure it, you have the
but you want to see the evidence.
The evidence.
The patient will not follow the instructions if they don't see that they make
from the
antibodies.
From the psychological view, it's very interesting to show the patient, look, this is a problem.
Yes. So scientifically speaking now, in one of those articles, they took antibody made against MAG, myelin-associated glycoprotein, stained neurons, of course. Anti-MAG stays MAG in the neurons. But they took anti-casein antibody and applied that to neurons. They stained as if exactly antibody against MAG was applied to the neurons. This is the proof of concept. Cross-reactivity between milk and neurons, and therefore you should remove milk in this case, from the diet of patients with possible multiple sclerosis and other autoimmune disorders.
We can call these antibodies the predictive antibodies. Huh?
Beautiful, yes, yes. In fact, I recently also read this article, one of the scientific journals, they're talking about predictive autoimmunity. Why? Because they started with type 1 diabetes. Now there is some kind of medication for prevention of type 1 diabetes, some kind of monoclonal antibody. And then they say, okay, now we can talk about predictive autoimmunity, while we started talking about that more than 20 years ago.
You are 20 years before.
Thank you.
Congratulations. another thing is very interesting regarding this blood-brain barrier. We see here this green monster. This is the blood-brain barrier, the glial cells or the astrocytes. And in these cells, or on the surface, or in these green barrier cells, we have receptors. They are called aquaporine receptors. What is aquaporine? Let me explain it quickly.
Yes.
These are the pumps, the green pumps between outside the cell membrane and inside the cell. And these important pumps, by the way, they need a lot of energy, ATP. That means mitochondrial support. The mitochondria have to work exactly good. Then they can pump water into our eyes, kidneys, brain, liquor rooms, and therefore these little structures are so important for our biochemistry, for functioning of the whole body. And the very interesting thing is that these aquaporine receptors have a molecular similarity to structures in the food. And can you explain us this a little bit more in detail?
Yes. An article was published in, I believe, Journal of Neuro-Immunology. It's a journal called Neuro-Immunology that showed more than 70% similarity between peptides, like 40 amino acids of peptides, meaning about 30 of them overlap with aquaporine in the brain, which is the water channel protein of astrocytic feed or foods. In cross-reactive studies, enough to have 4 or 5 amino acids of one peptide in order to produce cross-reactive antibodies. In here, we have 70% similarities. So antibodies produced against spinach, corn, tomato, and soy, if we'll get to the blood-brain barriers, can damage the aquaporine. And then open the blood-brain barriers, inflammation in the brain, and change in pathophysiology of the brain. Okay. In fact, I was reading one article. This is just one of them, right here, that I have with me, published in Cells. Just the title: Aquaporine 4 Water Channel in the Brain and its Implication for Health and Disease. And there are 10 different implications. I would like to read them, if you don't mind. One is BBB breakdown. Breakdown in blood-brain barriers. Number 2, traumatic brain injury. Okay. Brain inflammation, stroke, synaptic plasticity. Why? Because aquaporine influences the activity of brain-derived neurotropic factors.
BDNF.
Memory formation, the synapses. Learning. Lymphatic clearance. I'm sure you know that everybody thinks about lymph nodes and how much they clear the toxins from the body. But we have lymph nodes in the brain or something equals to that. Their job is at night when we fall asleep to clear the toxins. So they call that lymphatics. It was discovered about 6 or 7 years ago.
When you have a good sleep, then these channels enlarge 60%. They open more if you have a good sleep.
Yes.
If not, then the brain cannot clear the garbage out of the brain.
Yes. And finally, brain aging and Alzheimer's disease. Now, one more thing, let me add also, because we said antibody produced against this affects the water channel proteins.
Yeah.
What is the main job of water channel protein aquaporin? To prevent homeostasis between
Exactly.
outside of the brain to inside of the brain.
Yeah.
So imagine what will happen, Dr. Runow, if you get too much calcium in the brain, or too much sodium, or too much potassium. I'll give you one example. And I was reading in this article that too much calcium activates protein kinases. Too little calcium activate phosphatases. Each one of them have different implications. And so therefore, antibody produced against food aquaporin, its effect on brain aquaporin completely can change physiology of the brain.
Therefore, this is healthy food.
Yes.
Yeah.
Yes.
People, all my patients say, I eat only healthy food. Like, okay, what is healthy food? That is the question. It's very interesting to explain our patients, and of course our colleagues, that there is a problem caused cross-reactivity. And this is what we have to learn, and this is, therefore I'm so glad that you are here to explain us these information which lead us to a paradigm shift. We have to ask, is it a disease what the patient has, or is it a symptom? And these tools are very important to make this connection and to exclude, or to tell our patients that you can manage your disease, that you can change your lifestyle, or if you change your lifestyle, your diet, or your habits, then our immune system will come back into balance, back to normal, and the symptoms disappear. At the end, let me mention the Alzheimer links. This is a very amazing test, in my opinion, and this test should be recommended for people not in the age of 80. I recommend it in the age of 40, 50, because this is also a predictive test. And perhaps you can tell us some background to this test.
Yeah.
Because it's you see, there are a lot of growth factors, pathogens, chemicals.
So about 8 years ago, because my interest in cross-reactivity studies, one of the best way to do cross-reactivity studies is to take monoclonal antibodies. In this case, made against tau protein or amyloid beta, right there, amyloid beta peptide, and apply them to different environmental factors, including human tissue. And we found that those antibodies not only reacted to tau protein, amyloid beta, rhabaptin, presenilin, alpha-synuclein, they reacted also with brain-derived neurotropic factors and other growth factors.
They block it, then BDNF is destroyed.
Right. So we need those growth factors. What are growth factors? We need them for our revival.
Neuroplasticity.
Exactly, all of that. Furthermore, I was very surprised to find that those antibodies reacted with enteric nerve, vasoactive intestinal peptide, transglutaminases.
Again.
Yes. Okay. And then with some of the foods right there. Casein is there, alpha-gliadin is there, non-gluten proteins is there. And then with blood-brain barrier proteins, S100B, Claudin 5, and neurofilaments. And finally, with some pathogens, right here, all of that, the pathogens, and chemicals bound to human serum albumin,
like phthalates, aluminum, and phthalates in plastic
Yeah.
can also cause antibodies. And the important thing is that these antibodies can attack the amyloid beta 42 structures
Yes.
and disturb our, let's say, brain antibiotic, because amyloid is our friend. This is what
That's right.
Professor Tanzi said. It
Yes.
is our friend.
Yes.
And this is our antibiotic stuff.
It's antibiotics
It helps
produced in the gut.
So it is our friend. And if I have antibodies caused by these chemicals or pathogens, these parts, these antigens, let's say antigen, or then these antibodies against these structures can destroy my amyloid beta 42. Perhaps you can explain it a little bit better, but it's very difficult. I know we can talk about this 4 or 5 hours, but this is a preventive test. That it's important that we see what happens in my blood. Can I measure immunological attack to structures in our brain? We talked about the cross-reactivity, and this is also a kind of cross-reactivity with the potential to destroy my brain. Yeah.
First of all, this idea was published in Journal of Alzheimer's Disease years ago, and another one in International Journal of Alzheimer's. But other scientists also published several articles. For example, Ruth Isaki from London. For years, she worked on herpes type 1 and Alzheimer's. And now her latest article, it's with absolute evidence that herpes family viruses play a role in Alzheimer's disease. That's why we have herpes type 1 in here. The issue of, in addition to cross-reactivity that we showed, that oral pathogens play a role in Alzheimer's disease. You know why? Because oral pathogens, they release toxins. They don't need to get into the gut and from the gut to the blood directly through activation of T helper 17.
Oh.
Get the message to the brain and cause brain inflammation. Study at UC Davis, they took brain of patients with Alzheimer's, of course after they die, and they did section, and they found evidence of E. coli and Salmonella and Campylobacter jejuni in the brain of patients with Alzheimer's. We don't know whether they caused Alzheimer's, but at least we find them, in the crime scene. That's how they say.
Perhaps because they are not destroyed by amyloid beta.
Yes. So this is really one of the best panel, not only for Alzheimer's. If I was the MD and a patient walking to my clinic for the first time, and he said, I have only like $700, whatever the cost of the test is, I would like to spend it the best way. I will order these tests. Why? Because in addition to brain proteins, growth factors, you check the enteric nervous system as well.
Exactly.
All those peptides, transglutaminases in the gut. You check for pathogens. You check for toxic chemicals. You check for major foods. And finally, you look at blood-brain barriers, proteins, and autoantibody production against them. I don't think that, this is one of the best tests to check for overall body health, particularly for brain health in general, not just for Alzheimer's. So yes, it is preventive.
Preventive, predictive, this is an environmental test.
Yes. Now articles coming out about Alzheimer's disease is not induced by a single factor. It's a multifactorial. You and I were familiar with chronic fatigue fibromyalgia 30 years ago, 25 years ago, 20 years ago. Now they call it ME/CFS, which also overlaps with long COVID. Now Alzheimer's is multifactorial.
Therefore, it's
And
important.
so therefore
to check.
all of these play a role in Alzheimer's, and we cannot treat it with single remedy or single medication.
Exactly, and therefore,
Which what they
we
did. They did put emphasis only on amyloid beta cascade, which all the medications failed.
Therefore, now my patients ask whether what happens when there is a positive result. What can I do? How can we support our patients? How can we support our biochemistry? And I explain that we have to use such substances like vitamin C, glutathione. We have to support the detoxification. We have to support the mitochondria, because interesting thing is that the destroyed axons, they need more energy, and the mitochondria, they travel from the healthy axons to the destroyed axon.
It is interesting that, you know, mitochondrial dysfunction
Yeah,
is another factor involved in long COVID.
exactly, because the antibodies against SARS-CoV-2,
Yes. M2.
that they also can attack the mitochondria.
Yes.
That was
Yes.
very interesting.
Yes.
Yeah.
Yes. And the other thing is also, we know herpes type 6 is involved in long COVID, and there are receptors in the brain for herpes type 6. And herpes type 6 can damage mitochondria as well. So everything is coming
It's
together.
immunological attack.
Yeah.
Okay. Then let's come back to the end, to the treatment program. We call it Hepatox. This is our program. We give intravenous substances like mitochondrial support, carnitine, B vitamins, and so on. And of course, one big part of my work is to check what happens in the gut. We do a stool analysis and so on, and the food cross-reactivity tests. And so the very interesting thing is that we can do a medicine which is called the individual medicine, because every
Personalized.
person is a biochemist, biochemical individual.
Individuality.
And
correct.
therefore it's multifactorial, and we have to find out which part of these multis is very important for this person. Is it the gut? Is it the an increased or deficiency in vitamins, minerals? And what are your recommendations when we talk to our patients to support our gut, our mitochondria?
Yeah,
Do
the
you
gut
agree?
and blood-brain barrier and everything
Yeah.
together.
Yeah.
Yes. Number one, we should emphasize the importance of regulatory T cells.
Mhm.
And regulatory T cells, because if you explain to your patient the mechanism, how it works, they understand it
They
better.
understand, that is important.
They have receptor for vitamin A, vitamin C, and vitamin D.
Mhm.
Treg cells become regulated, and they produce TGF-beta and IL-10, which are regulatory cytokines that regulate the immune system and regulate the tight junctions at the same time.
So vitamin D, vitamin C, and vitamin A.
ACD, yes. Next, acetate butyrate propionate.
The short-chain fatty acids,
Yes,
to give the fuel to our
right.
gut cells.
Right. Then, if a single factor, which is so important for repairing the gut and blood-brain barrier, if someone will ask us, is resveratrol. Lots of publications about.
Resveratrol.
Maybe you should have your red wine, or capsules.
better capsules by
for-
red wine.
for resveratrol,
Because of the
whatever.
histamine, I have problem with it.
Yeah. And DHA, fish oil, DHA especially. I read articles almost 20 years ago about effect of DHA for blood-brain barriers. And even medication, such as minocycline, from tetracycline family of antibiotics, is very important for repairing the blood-brain barriers.
Yeah, this is
And
interesting.
lipoic acid with some questions, because lipoic acid structure is very similar to octanoic acid, which is which is found in many cosmetics that cross-react with the enzyme in the liver. I think some kind of phosphatase in the liver. And so because of that, we have to be careful, make sure that will not have any side effect in some patients, lipoic acid, because of that similarity in the structure with some chemicals in the cosmetics.
Okay, but I think alpha-lipoic acid is a very amazing substance. I recommend it very
Beautiful.
often. Yeah.
So it is good. It's very good for repairing
Also
the
the
blood-brain barriers. And finally, other, I don't know, ginger, green tea, and many others that you know better than me, is very important to use.
Yeah. Thank you very much for
My pleasure.
these intensive explanations, and make it for us more clear what happens in the biochemistry between environment, gut, brain, and other organs. Thanks a lot,
Thank you so much.
and let's see what we can transfer this evening in the seminar.
We thank you for teaching skills that I learned from you a lot. Thank you.
Thank you.
If you want, you can present a book, if you want to.
Ja. Nochmal das? Gib's mir mal. Ach so.
Maybe you start with, I want to mention one thing more.
Achso, jetzt muss ich aber dann...
For further
Von unten
information,
Ja. Genau, okay.
these are the books you recommend.
Ja.
And your book
Ja.
also. Yeah.
Ja, und for further information, let me recommend you the latest book from Professor Vojdani, Neuro-Autoimmunities. Here you see it, When Food Breaks Your Immune System. Very interesting. And here is, let's say, the espresso from this, as you mentioned, from his son, Aristo Vojdani. And I think this is what we recommend our patients. That's good to read. Thank you very much.
Yeah, when the food
Excellent.
bites back. And,
That's
and
interesting.
both of them really, the meaning of that is that, that breakdown in oral tolerance results in inflammation and autoimmunity. That's the meaning.
Very.
Thank you.
Now we have a lot to do the weekend. Huh? We have to read a lot. Thanks. And I hope other people can also find here and read here and find very good information and to help them in changing their lifestyle or understanding what happens in their body. That is exactly what I tell my patients. I want that you know what happens in your body. I don't want to prescribe a medication. That's,
So I would like to thank you again for,
thank you very
your
much.
friendship. Thank you.
Thanks. So.
All right.